Hello and welcome to today's lesson. This is Jupyter Notebook. This is where I run my Python code, script. Today let's talk about how to explore datasets, the libraries you need, and so on and so forth. Excuse me. If you're familiar with Python, it's quite straightforward. It's a very versatile programming language. Here you import NumPy as NP, numerical Python, I think you import Pandas, yeah, as PD, import Matplotlib .pyplot as PLT for visualization, import Seaborn as well. That's just to make the page look nice and readable. We'll be using clustering, so we import this k-means. K-means is a centroid-based clustering algorithm. It measures the distance between the data points from the centroid, from the mean. The import silhouette score for choosing the best cluster, the best number of clusters. And there you go. That's the data set. And that's the code to read dataset. pd.read underscore CSV. So you assign this df to this. Now you run the code. Df, simple. It could be anything. Could use data is equals to pd.read underscore CSV. You just, this now represents the variable. This is the variable. And this is the function. This represents this. So whenever you run df, this, the contents bar of this comes up. And that's what you have here. The data set. 1000 rows and 15 columns. You run df.shape, you get the rows and columns. Let's explore the top head, df.head. I mean the top bit of the data set. There you have the name, age, gender, these are the columns, these are the rows. And then there's the bottom bit of the data set, df.tail, df.describe, statistical analysis, the main, the main for the age is, main age is 51.4, thereabout. The standard deviation is 19.5. That's how far the data points are from the main. The minimum value is 18 for age, and the median age is 52, which is very close to the mean. Perfect. And the maximum age is 68 for these patients. Medical conditions. You have obesity, arthritis, sugar more, asthma there, right at the top. Names of Dr. K. This is not an actual lesson. I'm just practicing, so exploring the dataset at the same time. Let's check for missing values. df dot is null. Of sum. No missing value. Let's plot a box plot. This is a code that you can reuse at any time. You can just copy and reuse. Industry ready code. So you define the function histogram box plot, and that's the dataset you need, which we already have saved. And then feature, and that's the size of the figure. Kernel density, false. Things none. Data equals the data frame feature, the data frame column, fixed size, size of figure, okay, whether to show density curve, number of bins. This is just a comment section. So you define the function, and this will be executed. This box 2 histogram as well. PLT, the subplots and rows 2 data is equals to df, and that's it. Function is defined, and now let's plot the plots. Let's check the billing amount for the patients. As the median billing amount, it says around this 20,000 here, 30,000 in the middle, 20,500. Medication is labeled bar plot for medication. See here, penicillin was the most medicine prescribed. The highest, the most amount paid. Look at this. About 500 patients. Oh no, 550 probably patients paid just under 20,000. The median billing amount, which is about 20,500. I was paid by about 480 thereabout. Patience will build. Well, our test is done.